Hello learners, welcome to this course on Embedded System Design using AT89C51 Microcontroller. In this tutorial, I will be discussing about on how to interface a direct current motor with AT89C51 microcontroller. So a direct current motor, it translates electrical pulses into mechanical movement. So the polarity on the leads of the DC motor determines the direction of rotation. So for example, if I take one lead and connect it to a positive terminal of the battery and another lead to the negative terminal of the battery, let us assume that motor is rotating in clockwise direction. By just changing the leads to the battery potential, we can able to change the direction of your motor. So just by changing the polarity given to a motor, we can able to change the direction of rotation. So a DC motor, it rotates continuously and its speed depends upon three main factors. One is the load connected to the motor, voltage rating and current rating. So the DC motor has 2 RPMs, revolutions per minute, under no load condition and under loaded condition. Usually the manufacturer data sheet will specify the no load RPM. It may vary from few thousands to tens of thousands. When we talk about the current rating of the DC motor, is the current consumption of the DC motor when a nominal voltage is applied under no load condition. So the current rating can vary from 25 milliamperes to few amperes. By changing the voltage given to a motor or by changing the current given to a motor, we can vary the speed of the motor. Same way, by increasing the load, the RPM will be decreased. As the load connected to the motor gets increased, the revolutions per minute will get decreased. For smaller load, the speed will be high. For larger load, the speed will be low. And there is very popular technique, another popular technique to have a variation in the speed of your DC motor, that is pulse width modulation, where we will be generating a square wave with the different duty cycles. So the duty cycle is specified by the on time per the total time period. In a square wave, we will have on time and off time. So the total period is nothing but on time plus off time. So out of the total period, how long we are going to have the on time? That determines the duty cycle of a square wave. So for example, here in A, we have 50% duty cycle square wave. So the total period, out of this total period, for 50% of the time we have on time. So which means it is called as 50% duty cycle. In the graph B, we can see only for the 10% of the time out of the total time period we have on time. So thereby it is called as 10% duty cycle. Same way in graph C, we have 30% of the time we have on time out of total time period. So it is called as 30% duty cycle. And finally, in graph D, out of total time period, 70% of the time we have the on time. So by changing the on time in a square wave, what we essentially do is we change the amount of energy given to a DC motor. By changing the amount of energy given to a DC motor, the speed of the DC motor gets varied. So if we see the construction of a DC motor, it will have stator windings, which is fixed in nature, and at the center we have a armature, which is a movable rotor. So by changing the excitation voltage to the stator windings, the amount of magnetic field produced by the stator windings will get varied, thereby the speed of the DC motor can get changed. And the direction of exciting the stator windings will determine the direction of rotation of your motor. So here I show a typical DC motor. So in order to have a bidirectional movement, If I want to have a bidirectional movement, that is clockwise and anti-clockwise rotation, then what we essentially need to do is we need to remove the leads and change the leads connected to a polarity of your battery. So in order to have a connection where I can have a bidirectional movement without removing the wires from the circuit can be achieved using your L293D motor driver. So this L293D motor driver is a quadruple high current off H bridge drivers. So it provides bidirectional drive currents. So thereby I can easily change a motor direction from clockwise to anti-clockwise, from anti-clockwise to clockwise. So the bidirectional drive currents can be up to 600 milliamperes for a voltage between 4.5 volt to 36 volt. We can have a peak output current of 1.2 amperes and all inputs are TTL supported, transistor logic supported. So the main applications of this motor driver are in stepper motor drives, DC motor drives, latching relay drivers. Another main functionality of this L293D motor drivers is to give the appropriate current required for the motor to run. The microcontroller usually provides 25 milliamperes to 15 milliamperes of current through their port lines. So this current might not be sufficient for the motor to get driven. So in order to supply more current or the required current for the motor, we need to use this motor driver, which will divert the external power supply connected to it to the motor at the appropriate condition selected by the microcontroller. So the microcontroller will act like a switch, thereby diverting the external supply gets routed to your motor for its operation. So how we can get this bidirectional movement using this L293D motor driver? For example, here we have 4 switches, switch 1, switch 2, switch 3, switch 4, and the motor is connected at the center. One end we have connected it to the supply, other end we have connected it to the ground. So when we look at this, when all the 4 switches are in open condition, in that case the current will not go to your motor, thereby the motor will be in off state. That is this one. When switch 1, switch 2, switch 3, switch 4, all are in open condition, the motor will be in off state. If I try to close switch 1 and switch 4, in that case switch 1 is closed, switch 4 is closed, switch 2 and switch 3 are open. In that case what happens? The current flows from the positive terminal of the battery, it goes through switch 1 and it enters the motor on one side and it leaves the motor on the other side. It passes through switch 4 and it reaches the ground terminal. Since the current is flowing into the motor, what happens? The motor starts rotating in one direction. Let us assume that direction is clockwise direction. Then let us change the logic of the switch configuration. Here in the third configuration, what we do is we connect switch 2 and switch 3, whereas switch 1 and switch 4 in off state. In that case again what happens? The current from the positive terminal of the battery goes through switch 2, it enters the motor and it leaves the motor and goes to switch 3, from there it goes to ground. So now the current direction is changed. The current passing to the motor gets changed. So thereby the direction of rotation will be opposite to that of earlier version. So earlier if we have considered it as clockwise direction, now it will be counterclockwise or anti-clockwise direction. In the last scenario, if all the switches are closed, what happens? Now the current will go either through 1 and 3 and it will reach the ground, or it will pass through 2 and 4 and reach the ground. So thereby no current goes into your motor, thereby the motor will not run, and this is also an invalid state. So this is how the direction of rotation in a DC motor can be achieved just by configuring these 4 switches appropriately. So we need not remove the terminal and interchange it. Just by configuring these 4 switches properly, we can able to change the direction of current flowing into the motor, thereby the direction of rotation can be changed. Another important application of your L293D motor driver is it provides isolation between your electronic circuit and the rotating device. So any rotating device will produce a back EMF reverse voltage. So this voltage should not enter into the electronic device, otherwise it will damage your circuit. So it will also provide the isolation between your motor and the electronic circuits. So here I show a typical connection diagram how this L293D can be connected. So two motors can be controlled using a single IC L293D. So pin 13 and pin 12 will be coming from your microcontroller. So I can have a logic of 0, 1 or 1, 0. If it is 0, 1, motor will rotate in one direction. If it is 1, 0, it will rotate in opposite direction. And the motor is connected to this out 1 and out 2 pins of your L293D motor driver. And we can connect the external supply to the pin number 8 of your L293D. So this external supply will be diverted to the motor depending upon my pin 13 and pin 12 from your microcontroller. And there is a enable signal for controlling or enabling the activities of your motor 1. Same way there is a separate enable signal for motor 2. So these two enable signals should be connected to the 5 volt supply. Thereby the enables will activate your motor for its proper operation. Now let us go to the interfacing part. So here I am going to use Micro C Pro for AT51 as an integrated development environment where we will be writing our C program and we will be converting that C program into a hexadecimal file. And we will be building our circuit using Proteusite Professional Simulator. Then we will try to load that hexadecimal file onto the microcontroller IC and we will check whether it is working properly or not. So here I show a typical block diagram where I use AT89C51 microcontroller and I am going to connect two switches to port 3.0 and port 3.1. So the port 3.0 will be used for enabling the motor to rotate in clockwise direction, whereas port 3.1 will be used for enabling the motor to rotate in anti-clockwise direction. So we are going to connect the motor to port 2.0 and 2.1. So it gets connected to your L293D motor driver. So port 2.0 is connected to input 1 terminal of your motor driver. Same way port 2.1 is connected to input terminal of your motor driver, and the enable line is connected with the supply. And also we need to connect the appropriate supply required for the motor to the motor driver. Then the out terminal from your L293D motor drivers will be connected to your DC motor. So here I show a typical circuit which we try to build on a Proteus environment where we use this XTAL1, XTAL2 connected to your oscillator circuit, and I am going to connect 10 MHz crystal oscillator. Then we are going to have a reset circuit connected to the reset pin of your AT89C51 microcontroller. So by default this pin will be at logic low. As soon as I close the switch, this pin will go to logic high, thereby reset operation can take place. And we have connected two switches to port 3.0 and 3.1. One is called as forward, another one is called as reverse. Whenever I close the switch, the pin will go to logic 0. And we connect port 2.0 and 2.1 to the L293D motor driver in 1 and in 2, and enable line is connected to your supply. And we connect the power supply to be again VCC, and this power supply will be routed to your motor depending upon the value at this 2.0 and 2.1. Now let us look at the program. So in a main program, first I define the lines. Port 3.F0 is the location where we are going to connect a switch. So it is configured as 1 by putting a value of 1. Port 3.F0 equal to 1, which means we are configuring port 3.0 as input. Same way port 3.F1 F1 we are going to connect another switch, that also we configure it as input. Same way we use port 2.F0 and F1 are configured as output. So in order to configure it as output, we specify a value of 0 to this port pins. Then in a while loop, I am going to check whether the first switch, port 3.F0 is pressed. If the port 3.F0 is pressed, it will go to a value of 0. Here port 3.F0 is pressed, port 3.F1 is not pressed. In that case, I rotate the motor in one direction. So by giving a value of 10 to this port 2.F0 and port 2.F1. If the second switch, port 3.F1 is pressed, in that case I am going to change the logic. Other conditions, like when both the switches are pressed or both the switches are not pressed, I am going to deactivate the motor by providing 1 to port 2.F0 and port 2.F1. Now let us go and see the circuit. So here I have created the DC motor interfacing with AT89C51 microcontroller. Here you can see the oscillator circuit connected to XTAL1 and XTAL2, reset circuit connected to RST. Then we have connected the L293D motor driver to the microcontroller, and there are two switches, forward and reverse. Same way the program is written in Micro C Pro for AT51. So the program I have explained here. So after writing the program, we need to convert this C program into a hexadecimal file. For that I perform the build operation. When I perform build operation, it gets compiled and it gets converted into a hexadecimal file. Once it has been converted into hexadecimal file, we go to Proteus, right click on the IC, edit properties, load that X file. This is the X file which we have created, DC motor. Try to load that X file into the microcontroller, set the oscillator frequency, press OK. Now let us check whether the circuit is working properly or not by pressing the play button. So right now the motor is in off state. When I press forward, you can see it starts rotating in clockwise direction. When I press reverse, it starts rotating in reverse direction. When both the switches are pressed, it will be in off state. Same way, when both the switches are in off, also it will be in off state. So this is how we interface a DC motor with AT89C51 microcontroller. Thanks for watching. Please subscribe for more technical learning. Thank you.